One celebrity tweet just generated 50 million writes, freezing feeds for 30 seconds. Here's exactly why. Let's start with the basics of fanout. Welcome to TheCodeForge. Before we dig into that production issue, let's cover design Twitter feed. A Twitter feed is a timeline showing tweets from users you follow. The core challenge is fanout, distributing a single tweet to all followers. There are 3 models: push, pull, and hybrid. Production Twitter uses a hybrid approach. Push fanout means when a user tweets, we pre-compute and store the tweet in every follower's timeline cache. Read is 0.1, but write cost is 0 followers. It's like mail merge, each subscriber gets a personalized copy. Pull fanout means on timeline load, we fetch tweets from all followed users and merge. Write is 0.1, but read cost is 0 followers. It's like an RSS feed, no hotkeys, but reads are expensive. Hybrid fanout uses push for users with fewer than 1 million followers and pull for celebrities. This balances write and read load, avoiding the hotkey problem. The fanout service checks the author's follower count. If it's above the celebrity threshold, it only pushes a summary to a small cache. Otherwise, it pushes the tweet to all followers using a thread pool. Here's the fanout service code. It checks if the author is a celebrity. If so, it pushes only to a small celebrity cache. Otherwise, it pushes the tweet to each follower's timeline cache asynchronously. The timeline cache is the heart of read performance. For each user, a Redis sorted set stores tweet IDs scored by timestamp. On read, we get the top 200 IDs and hydrate them with full tweet content from a separate cache. This code manages the timeline cache. On a cache hit, it returns the top 200 tweet IDs. On a miss, it rebuilds the timeline by fetching recent tweets from followed users, ranking them, and populating the cache with a 5-minute TTL. Ranking turns a chronological list into a personalized feed. The pipeline gathers candidates, extracts features like recency and engagement, scores them with an ML model, and returns the top 200. Model latency must be under 50 ms. This simplified ranking model extracts features like engagement rate, recency, and media type, then uses a pre-trained model to predict engagement probability. The top 200 scored tweets are returned. When a celebrity tweets, push fanout would require millions of writes, overwhelming the fanout workers. The solution is hybrid fanout. Celebrities use the pull path, so their tweets are not pre-pushed. This celebrity cache stores the most recent 100 tweets per celebrity in memory. When a follower's timeline rebuilds, it fetches from this cache instead of pushing to all followers. This is the same issue we highlighted at the start. Here's exactly why that happened. A celebrity tweet triggered a full push fanout, generating 50 million writes. The fanout workers were overwhelmed, queues overflowed, and feeds stopped updating for 30 seconds. The fix was to move celebrity users to a hybrid fanout. Their tweets are not pre-pushed. Instead, followers pull those tweets during timeline read. This reduced peak write load by 40% and eliminated the hotkey bottleneck. The key change was checking follower count celebrity threshold and routing to the pull path. Without a rebuild feature, multiple concurrent requests can all trigger a rebuild simultaneously, overwhelming the database and ranking service. Always use a coordinated rebuild pattern. If the ML model crashes, the feed load fails. Always maintain a simple chronological sort fallback to ensure the feed always loads. A static threshold can be problematic. If set too low, you still have hotkeys. Too high, many users cause spikes. The threshold should be dynamic based on current fanout worker queue depth and cluster capacity. The article mentions a threshold for hybrid fanout, but doesn't show how to adjust it dynamically. Here's a production pattern that monitors fanout queue depth and adjusts the threshold every 5 seconds to prevent overload. The article mentions using a feature to avoid Stampede, but doesn't explain the exact mechanism. In production, use a loading cache with a single-threaded rebuild per key, e.g., Guava's cache builder, or a concurrent hash map with compute if absent. This ensures only one request triggers the rebuild while others wait on the same future. When rebuilding a timeline that includes multiple celebrities, fetch their recent tweets in parallel to minimize latency. The article mentions querying celebrity caches in parallel but doesn't show code. Here's an example using completable future. To debug feed issues, check fanout lag for a specific user, monitor timeline cache hit rate, profile ranking model latency, and use synthetic users to measure real user-perceived freshness. Let's run through some common interview questions. Design Twitter timeline, hybrid fanout Redis cache ranking pipeline, handle celebrity problem, hybrid fanout with dynamic threshold. Trade-offs push versus pull optimizes reads, pull optimizes writes, hybrid balances. Ranking pipeline latency, 50 ms budget, fallback to chronological sort. And a few frequently asked questions. Why not push for celebrities? 50 m writes per tweet overload system. How to keep ranking fast? Quantized models, 50 ms budget, fallback. What happens on cache miss? Rebuild with coordinated future to avoid Stampede. Key takeaways: hybrid fanout separates normal users from celebrities to avoid hotkeys. Timeline cache with Redis sorted sets enables O1 reads. Ranking must have a fallback. The fanout threshold should be dynamic. Ready to go deeper? Up next, design YouTube, then design WhatsApp, then design Uber. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.